Here is the review for chapter 1 and 2. We are doing the practice for quiz 1. So the question here covers pretty much everything I need to know about chapter 1 and chapter 2. So I'm going to go over this with you, and you can just go over this video with me, and also send me an email if you have any questions, because we're going to have the quiz on Thursday. All right, now, first question here is MTH 245, Spring 25, and we're preparing for the first quiz. First one. Researchers at Yale University conduct a wide variety of study of the relationship between eating breakfast and GPA by using 205 subjects who volunteer after reading advertisements soliciting paid volunteers. Number A, is 205 a sample size or a population size? These researchers, they want to conduct the survey, or they want to do the research to see the relationship between the eating breakfast and the GPA. So they suppose if you want to do that for the school, then they should use the whole university as their everybody in the university as their all the students as their population. But this one we have only 205 volunteered to answer the question. So 205 is a sample size. It's not a population size. And then I'm going to ask you to show me that mathematically using the correct expression, and n equals 205, and you might say sample size. Okay, that'll be good. All right, now next question. What method was used to collect data? I give you 4, and you just let me know which one. The first one is random sample, which is you randomly select 205 students from the school. Second one is a self-selected sample, which is the people who volunteered or who came to you and give you the answer. And that is this case. So in our example, the answer should be the number 2, the self-selected sample. Okay, and it's not a stratified random or a cluster sample, which is more complicated. Okay, so that is something about question number 1. Number 2. Identify the following data type, and I only ask you to pick from the 4: nominal, ordinal, interval, or ratio. If you remember, nominal is the lowest one. It's more like a labels, okay, and doesn't have any order or any other specific relationship there. So nominal. And the next one is ordinal, when order matters, okay. And then the next one, go to the quantitative. We have an interval. Interval makes sense. And the last one is ratio. Ratio makes sense. Now, community college ranking. Community college ranking, this school ranked number 1, the other one ranked number 2, and the other one ranked number 3. It looks like they're numbers, right? And if they're numbers, you always look at whether it's interval or ratio. Now, does ratio make sense? Is the number 2 school twice as good as number 1? Of course not. Okay. And what about the interval? The difference between the number 1 and number 2 is the same as the difference between number 5 and number 6? Of course not. So it's not quantitative. Therefore, it's not interval. It's not ratio. What about an ordinal? The order matters, right? The rank order. Number 1, number 2. Yes, number 1 is better than number 2. Number 2 is better than number 3. So we should say ordinal here. Okay. And the length of prison sentences, 5 years, 10 years. Now, if you remember that we mentioned about it, the year, usually we think, oh, that might be interval. But this one, we talk about the length of the prison sentences. The time, actually, it's not really just year, it's a time. Okay, when time comes, you're going to say 10 years is twice as much as 5 years, right? So ratio makes a sense. So this one is a good ratio data. All right, now the area of 50 states in square kilometers. We talk about the area. So we get a measurement, comes a number, and comes with a unit, right? Square kilometers. And the ratio makes sense because if the number is twice as big as another one, therefore the area of that state is twice as big as another state. So this is also ratio. Okay, next. The year in which the baseball World Series is won by team from the National League. Okay, we talk about like a 2022, 2023, things like that, and that's a very, very typical interval. We talk about a year. Okay, body temperature, interval. Two very popular examples of the interval data. Okay, temperature and year. Actually, there's another one. Shoe size. Shoe size 8, 9, 10. Okay, 10 is not as twice as big as 5, but 8 to 9, 9 to 10, 10 to 11. The difference or the interval between the two consecutive numbers are the same. So that's another interval. But here, there's a two interval. Eye color. Eye color of all students in MTH 245 class could be black, brown, blue. I don't know. I didn't pay attention to that, but the eye colors comes as a nominal. No order, right? It just labels. Even you call black 1, brown 2, it's still nominal. Okay, next one, SAT score. SAT score. Does ratio make sense? Is 800 twice as much as 400? Of course not. And what about an interval? We don't know, but for sure it's an ordinal, right? And guess what? When they do that, they make that interval. Okay, that means the difference between like a 790 to 800 is the same as 710 to 720. So that's what it says. And the last one is the Social Security number. Social Security number is a very typical nominal. Okay, they're just numbers. Numbers, or the Social Security number looks like a number, but it's not an actual number. It's like a label. Okay, they're just a number to make it easier because it doesn't really have an order. Someone was born after another one might have a greater or might have a smaller Social Security number. So that's a nominal data. All right, now we're going to look at the question number 3. For the given distribution table, answer the questions. Age in years of best actor when Oscar was won. We have the frequency, we have the age, 20 to 29, 30 to 39, 40 to 49 stuff. And then we have the frequency, and I give you another column called relative frequency. Okay, now I would ask you the following questions. Number 1, how many individuals are included in the summary? How many individuals are included? Okay, once you have the frequency of each class, you just need to add them up together. So you add a 1 and a 29 and a 38 and a 16 and a 6 and 1. Just add them up. So I take out my little calculator. Okay, I'm going to do that here. 1 plus 29 plus 38 plus 16 plus 6 plus 1. Total is 91. So here is 91. Okay, I always like to put the total at the bottom. So how many individuals are included in the summary? 90, right? And then the lower limits of each class, which is the starting number. So they are 20, 30, 40, 50, 60, and 70. Okay, and the class width. Do you remember the class width? We just used the starting point to see the difference. So 20 to 30, 30 to 40, so the class width is 10. Every 10 years of age, we put them into the same class. All right, next one, I ask you to complete the table with the relative frequency, which is here. I ask you to fill in this. And the relative frequency is the frequency divided by total. So that will be 1 out of 91, 29 out of 91. So let me show you how do I do that. Okay, so that would be 1 divided by 91. You have this number, you have a 0.0109890. Okay, so I would ask you to keep 3 decimal places. So that would be 0.011. 0.011. So that is the relative frequency of this guy, of the first one. All right, now the next one will be 29 over 91. So 29 divided by 91, 0.319. So I have a 0.319. Next one, 38 over 91. All right, 38 divided by 91. I have a 0.418. So I get a 0.418. And the next one is a 16. 16 divided by 91. I have a 0.176. 0.176. And then 6 divided by 91, 0.066. 0.066. And the last one is 1, so I can just copy from that number, 0.011. Always calculate the total of the relative frequency to make sure that you get the right answer. You add them up, that should be 1. But let's do it. Let's see what happened when we add those numbers up. 0.011 plus 0.319 plus 0.418 plus 0.176 plus 0.066 plus 0.011. Ding! I got a 1.001. Where is this 1 coming from? Rounding error. Remember, we only keep 2 decimal places, and so we have some rounding error there, but you can just put a 1. If you find your answer is like this, 0.001, then you just put a 1 there. If you have something like a 1, 1.001, or 0.999 is really close to 1, you know it comes from the rounding error, you can just put a 1 here, and you know you're doing things correctly. So, okay. And the last one, I ask you to use the age as x-axis to construct a histogram for frequency distribution. Frequency distribution. And I have to have a 20 to 70 as x-axis. That's how you do it. Okay. So you draw this. X, okay, that's age. And Y, that is the frequency. So you probably want to start from 0, and then you're going to have from 20 to 30 to 40, 50, 60, 70. Even you don't have it, I still put 80 because my last group is from 70 to 79. And in case I have something more, it should be 80 or above. All right, now the frequency here, if you remember, 1, 29, 38. Okay, let's remember the first 3. So 1, so which is the height here, and the maximum number is 38. So I need to put maybe up to here, I put a 40. Okay, so that would be plenty. And here is 20, and here is a 30, and here is a 10. That sounds good, right? So 1, from 20 to 30, there's only 1. So that's a height. Okay, I like to put the frequency on the top of the bar. of this little bar. And the next one is 29. 29, it goes up to here. It's really close to 30. So make sure that you have that. It's a bar or it's a histogram, and then you put a 29. So just in case if when you draw that it's not so accurate, at least you show the number, I can tell. And the third column is 38 and 16. So 38 that go up here is 40, so 38 might be here. Okay, and it goes. I'm not very good at this, but that's good enough. 38. The next one is a 16. Here's 20. Here's 15. So 16 should be slightly more than that. 15. So I put a 16. Okay. Last two frequencies are 6 and 1. So the height of that should be just 6. And the last one is 1. Okay, so I shade those. I put a 6 and 1. Okay, I'm done. And this is a very, very good answer. So if you show me the histogram for frequency look like this, you get all the points. Okay. Number 4, the scatter plot of time running versus body fat looks like this. Here, the x-axis is time spent running, and this y-axis is the body fat for some kind of a measurement. So you can see the more time or longer time that people spend running, they tend to have lower measurement of body fat, isn't it? All right, now let me ask you this question. What is the sample size? Do you remember each circle represents one sample? It's paired data. The paired data is how long you spent in running and how much is your fat, body fat. Therefore, we only need to count like how many circles are there. So therefore, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Up to here is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the sample size is 29. Okay, is that okay? Now from this scatter plot, the variable time spent running and the body fat is that a positive or negative correlation? If you draw a line, it looks like this, right? Longer you run, less body fat you have. So that is negative. Okay. Next one. The test on linear correlation coefficient R has a p-value. P-value was 0.04. What is your conclusion? Now, do you remember what we did for p-value? And what does p-value mean? Okay. If you forgot, because we just did that. If a p-value is greater than 0.05, then nothing happened. But this p-value equals 0.04, which is less than 0.05. What does that mean? That means there is a linear correlation between the two variables. That's a lazy way to write it. Of course, you can say there is a linear correlation between the variable time spent running and the body fat. That's the same thing. If you want to answer the full list to give you the two variables, that's totally fine. All right, so those are the 4 questions that I put as the practice for our first quiz. I hope that you can just go over with me and make sure you understand everything. If you do that, you can do that correctly. Then you should be okay in the quiz. Otherwise, please ask me questions, okay? All right, good luck.